Let's take a closer look at the proximal tubule, the portion of the nephron that is most active in reabsorption and is the site of action for carbonic anhydrase inhibitors. Carbon dioxide easily diffuses from the lumen of the proximal tubule into epithelial cells. Once inside, carbon dioxide binds to water, and with the help of carbonic anhydrase 2, carbonic acid is formed. It then dissolves to form hydrogen and bicarbonate. Next, this hydrogen is exchanged with sodium through a channel known as the sodium-hydrogen antiporter, or exchanger, labeled here as NHE3. Once in the lumen, hydrogen ions bind to bicarbonate to form carbonic acid. Carbonic anhydrase 4 then cleaves carbonic acid to form water and carbon dioxide. Meanwhile, the bicarbonate from the breakdown of carbonic acid is reabsorbed into the circulation through sodium bicarbonate cotransport channels, or NBC1, followed by sodium. Thus, for every hydrogen ion excreted, one bicarbonate ion is reabsorbed into the circulation. On the basolateral border of proximal tubule cells, the sodium-potassium ATPase pump exchanges 3 sodium ions for every 2 potassium ions. This creates the sodium gradient that's used by the sodium proton antiporter. Due to this concentration gradient, potassium ions within epithelial cells diffuse freely through potassium channels into the circulation. The mechanism of action of carbonic anhydrase inhibitors. Carbonic anhydrase plays a key role in sodium and bicarbonate reabsorption, as well as acid secretion in the proximal tubule. Again, carbon dioxide easily diffuses across the membrane into epithelial cells to bind water with the help of carbonic anhydrase 2. Carbonic anhydrase inhibitors, or CAI, such as acetazolamide, bind to carbonic anhydrase and prevent the formation of carbonic acid. Therefore, the sodium exchange with hydrogen, described earlier, is prevented, which will affect subsequent formation of carbonic acid in the lumen. This will cause decreased reabsorption of sodium and bicarbonate from the lumen, which can result in metabolic acidosis.